For decades, Pluto has remained one of the most mysterious worlds in our solar system, frozen, distant, and silent at the edge of sunlight. When NASA's New Horizons spacecraft flew past it in 2015, humanity saw its icy mountains, nitrogen plains, and glowing blue haze for the first time. But buried in that data was something no one could explain: Pluto was far too cold. Models predicted 73 degrees Celsius, but the atmosphere was over 30 degrees colder. Something was draining heat from Pluto in a way that defied physics. For years, scientists searched for answers, recalibrating sensors, testing models, but the mystery deepened. Then, in 2017, Dr. Shi Zhang of UC Santa Cruz proposed a radical idea. What if Pluto's haze wasn't just passive dust, but an active, chemical system regulating temperature? The tiny particles high above Pluto's surface, Zhang suggested, might absorb ultraviolet light and re-emit it as mid-infrared radiation, cooling the planet instead of warming it. His theory predicted a faint infrared glow, when only the James Webb Space Telescope could detect. In 2023, Webb finally looked. Using its mid-infrared instrument, it observed Pluto and its moon Charon separately for the first time. The results were shocking. Pluto's atmosphere emitted a powerful infrared signal far beyond what its frozen surface could produce. The haze itself was glowing, radiating energy into space. Dr. Zhang's theory was right. Pluto wasn't just reflecting sunlight, it was actively cooling itself, functioning like a planetary thermal shield. These haze particles, called tholins, are complex organic molecules formed when ultraviolet light hits methane. On Earth, similar reactions may have created the building blocks of life. Webb's data showed these tholins contain nitrogen and oxygen bonds, ingredients of amino acids, and their behavior followed a repeating rhythm matching Pluto's 6.4-day rotation. The haze wasn't random. It was synchronized, breathing with Pluto's daylight cycle like a living system. Even more astonishing, the same phenomenon appeared elsewhere. When Webb turned its gaze toward Titan and Triton, it detected identical infrared glows. These distant icy worlds seemed to share a hidden mechanism, atmospheres radiating away energy, regulating themselves, perhaps even nurturing prebiotic chemistry. Pluto, it seemed, was not an anomaly but a prototype. But then the mystery deepened. Webb's later scans of Pluto's night side revealed something no one expected: a faint, rhythmic light pulsing every 247 seconds. At first, NASA thought it was reflection from Charon, but the pattern was too precise. When scientists analyzed the pulse, it contained mathematical ratios: 1.618, 3.14, 2.718, the golden ratio, pi, and Euler's number. These are the constants that define structure across the universe. It wasn't random noise. It was encoded. NASA quickly classified the data as instrumental interference, yet leaked notes from independent researchers told a different story. The signal didn't come from Pluto's surface, it came from beneath it. Webb detected echoes bouncing off a layer of metallic material buried 12 kilometers below the ice, forming a vast, spherical structure spanning nearly a third of the planet's diameter. For decades, Pluto was thought geologically dead. But now, faint tremors synchronized perfectly with the infrared pulses, as if something deep inside was alive, or operational. Each pulse repeated the same mathematical pattern, the same sequence that describes the fabric of spacetime itself. Some scientists whispered that the signal was not natural, that Pluto might be more than a world. Perhaps a construct. A relic. A machine. Officially, NASA dismissed it as an atmospheric anomaly. Unofficially, several researchers resigned after being asked to sign non-disclosure agreements. One leaked note contained a chilling line: "Pluto is not what we thought it was, it's something built." Since then, the faint pulse continues, sometimes strong, sometimes fading, as though responding to our gaze. Every repetition carries the same coded constants, the same universal language written into reality itself. So now the question isn't why Pluto is cold, but who designed it to be. And as the James Webb Space Telescope continues to watch that frozen world at the edge of our solar system, one can't help but wonder, the next time it pulses,